There you go. We're on the record now. Anything you say will be.
Do you want to share the screen too? I think you never read the presentation, Mike.
Did you hear about a study that Western Washington University did on the?
Just gotta share on the bottom.
I haven't
Sitting up so here.
seen that. No, go ahead.
I was in a meeting last week.
I've heard that they were doing as much, but I didn't. Yeah, I'd be curious what they're,
Yeah, it was kind of a sticker shock.
really, yeah.
Hi, how are you?
Highly.
These aren't orderers. No.
Oh,
Yeah.
There's a Jimmy John's truck out there, I think. Maybe. I'm an intern with Idaho.
Hi, Robin.
Heather.
Good.
Good.
It's been a while. Yeah, good to see you again.
So
I think we start here. You're back. How was it?
It's really.
You went
here for an introduction.
I could probably read this. No big deal now.
Weird.
Oh,
Not quite.
A couple minutes.
Yeah, Heather said you were on the plane out of town.
give it a couple.
Yeah,
That
just
was
in case
the
we have
next
more
thing
online.
I I'm like,
Sign in.
I think that.
And as we say, I think that a nicer picture.
Better than a quarter, I think.
Better be. It's only 93 minutes.
It makes me nervous because there's a couple of geologists in the room.
Uh-oh.
There's
You gotta watch out for that.
Watch out what I said.
I know.
Crowd.
There's only one that knows anything about it. That's he's down there.
Yes.
And you can go outside. There, that area.
Mhm. Yeah, and then that little garden area. We're gonna have a Wisescape
Oh, nice.
display there, so.
We have the last phase of the City Hall Wisescape starts in a couple weeks. That'll be the last of the grass at City Hall goes out. There'll
Wow,
be no more grass.
it's looking really nice.
It does, it looks really good, yeah. Nicole designed this space for us again.
Oh, she did?
Yeah, it was nice to have her background doing
I guess I should have put that in white.
What
The stuff.
is, oh, they can read the top part, that's the part that's important. I'm not that important.
So are you a student?
I just graduated from Lewis Clark State College,
Okay, in what?
Earth Science.
Earth science, okay, okay.
Where was that picture taken, John?
You know that old crusty fellow there?
Is that-
Saddle Ridge.
Saddle
The
Ridge.
name is so familiar, oh my
it. All right,
goodness.
we're at 3 o'clock.
Wow.
What, I'm sorry.
Bluebird Lane.
Yeah,
Okay.
We're at 3
I was
o'clock.
trying to get my
folks.
bearings.
We're gonna go ahead and get rolling.
I live between Pullman and Moscow, so. Yeah.
Big thanks to Dr. Bush, Emeritus Professor of Geology and
Geology.
Spatial Sciences, is that?
Well, that's what it is now, yeah.
Yeah, okay, awesome. Well, thank you. I'm Tyler. I'm the current chair of the Palouse Basin Aquifer Committee, and we're super happy to have Professor Bush here to talk to us a little bit. And so I don't think we need much further ado than that.
Can we go around just so everyone,
Yeah, we can do quick introductions. Yeah, I'm Tyler Palmer, City of Moscow, Public Works Director and current PBAC Chair.
Earl Bennett, long retired from the U of I.
I'm Jeff Lanigan, to enunciate the Lanigan, not Langman. I'm in charge of the utilities at WCU, so I'm the WCU representative. I'm the vice chair right now for PBAC and the technical committee chair, so.
I'm Reed Lewis, and I work for the Idaho Geological Survey, research geologist.
I'm Kylie Wilson, I'm an intern with the Idaho Geological Survey.
Oh, Kimmel Business and Public Affairs with Avista, but I represent Latah County on PBAC.
Robin Nimmer, Alta Science and Engineering, and former student of John Bush.
Pamela Dunlap, retired USGS and helper.
John, let's save your introduction for when you start your presentation. Let's jump back to Dave.
Dave Hall, long time Latah County resident and fighting for environmental causes, aquifers and Palouse prairie and earthworms and highways in the Latah County area,
Mike.
retired.
And I'm Mike Falpel with PBAC.
And then we'll jump online, Kara.
Yeah, Kara Haley. I'm a current member of PBAC. I work for the city of Pullman as their city engineer.
And then I believe it's Lucina.
Hi, I'm Lucine. I'm a postdoc with Greg Muller at the University of Idaho and will be starting a new job with Washington Ecology in 2 weeks.
The water some pitch worked. Carolina.
Hi, I'm Carolina. I am a graduate student at WSU. I work with Professor Yambal and I'm from Brazil. I'm here just for exchange of 6 months.
Great, welcome, thank you, Chris.
Chris Beard, hydrogeologist with the Water Resources Program at Washington State Department of Ecology.
And Hannah.
Hi there. Oh, there we are. I'm Hannah Hammerly. I'm an assistant professor in the School of the Environment at Washington State University. I'm a social scientist, but I work on water governance and policy issues. Nice to meet everyone.
Great, Hannah, thank you. And John?
She was at this.
Oh, hello. I'm Jan Bol. I am professor in civil and environmental engineering. Nice to see you all.
I think that was everybody. All right, Professor Bush.
I guess everybody knows me, John Bush. And I'm here to talk on what I call Granite well reports. I'd like to thank PBAC for giving me this time. Special thanks sometime to Steve Robuchon, who over the years has helped me dig up old literature. If you look at one of my modules, to understand Palouse Basin geology, you have to go back through the hundreds of reports that go way back when. The main reason, from a geologist's point of view, this place is ugly. There's not enough outcrops. So the only way you get your data is past knowledge, because a lot of the outcrops get covered, and you got to use well reports. And one of the reasons that we're here is here's a picture of a well you set out on Saddle Road up heading towards Twin Peaks, I believe. Anyways, we can locate a lot of wells right now off of the computer. The old days, we had a stack that we somehow gathered from the drillers of the state and tried to find some data. We were helped a little bit by Kylie Wilson, but I'm weak on numbers. Anyways, they've been helping us add to that, and Pam now probably has over 150 wells in a Granite area. We're trying to locate in a little more detail though, because when you take it off the computer, you can't see everything. Drillers don't always get it right. Names change in the drill logs. And in a couple of places, we'd like to draw some detailed cross sections. Well, like this well, it's 500 feet from the house, and it's about 20 or some feet lower, which is not a big problem if you're doing one of these maps where you're just drawing lines between them. But it is a problem if you draw a cross section, because at 20 feet or 40 feet or 500 feet can be a problem. So we've been trying to locate some of the wells a little closer than we used to. That's one of the reasons here. The other one is that 4 maps made back in 1995 by mostly my students and me taking a pencil and drawing lines are a little outdated now. So with all this new well data, we can find, maybe help Reed Lewis, who's mapping in the area. He's going to help, we hope, at least for the 1.5 miles along the border, find out mistakes we've made and get better, accurate lines. And of course, I believe my motto always is, the better the geology, the better the understanding. And I've always believed, I'm going to speak from the geologist side, but you've got to interfinger all the disciplines in order to understand the Palouse Basin. It is a complex subsurface, and that's why the water is complex. The rocks control the water. And when I came here in '67, I was told it's granite up there, but salt down here. We have 2 aquifers in Moscow, 1 aquifer in Pullman. The salts don't correlate across the way, and we're not interconnected. That's what I was told when I came to town. I went and worked in another state because there were no outcrops here. That was the approach back then. There were 25 grad students at WSU, 23 of them were working out of state or somewhere where there were rocks. That's just the way it was. But over the years, got the interest primarily from PBAC's work with my students. And so over the years, I slowly switched to being interested in the subsurface. Subsurface geology is very interesting. So, but while you're always looking at well reports, because that's actually the main source of geologic data. There are a couple of outcrops, but not very many. Okay, we need to probably go on to see what I was supposed to say next. Oh, yeah.
That's,
Okay, just about, so we're gonna have to back the 101 and review granite and weathering. A little bit about Latol formation terminology. I think I've already sort of covered why study granite well reports, exposures, difficulty interpreting the reports, an example of some of the interpretations we are making, some preliminary results, and some working models, working thinking, and some questions on any topic. Another reason why we're studying the well reports is that I never did those. We did a set for PBAC, some people might remember, we looked at over 500 wells in the basalts, about 6 years ago, and helped me understand the basalts, help us understand the basalts. I ignored the granite, only Earl Bennett or Reed Lewis would like granite, so nothing to me, so I didn't have any wells in the granite. So this is the first time, get the chance, I did some stuff for Jeff, who back about 4 or 5 years ago, and I suddenly realized I don't understand these granite wells. So let's see, let's get the terminology up there. The review of the granite and weathering next. Yeah, next slide. Yeah, no, I'm sorry. We have to go back to 101 just for a minute. If we're gonna go look at granite, what's granite made of? Quartz, muscovite, feldspar, biotite, amphibole, and peroxide. That's the main component. So the bottom three, we sometimes call ferromagnesium minerals. The feldspar and the quartz are sort of important to what we're doing. The feldspar breaks down pretty easily. All those ferromagnesium minerals break down in weathering pretty fast. If you go out and start poking around on Moscow Mountain or anywhere there's granite or anywhere near granite, you're gonna see chunks of big quartz. You're gonna dig in your hand and dig into the thing, you're gonna get quartz because the weathering has gotten rid of most of the other stuff. And just to remind you, the weathered feldspars and magnesium, if you weather all that, this is what you get. You get kaolinite, and you can turn that around. If you don't know what kaolinite is, a white clay, and some of you might know, there's extensive weathering in the past. Moscow's underlaying. If Moscow wasn't there, it'd be a good deposit for mining, the deposit of kaolinite layers. And when you weather the feldspars off of Moscow Mountain area, you're gonna get a lot of kaolinite. You get some dissolved ions. The only one I'm gonna concern myself with in there is iron. The reason I'm gonna be interested in the iron is that the iron moves through the system and leaves traces because it stains everything. Those who have been back here in the 60s and 70s know that it, including staining your fixtures in your house. So I can trace it, in my mind, trace it from the outcrop right on through the system to what's coming out to your faucet, because I can see the iron. The other ones take high level chemistry. That's not me. Okay, so let's take the next slide here. This is out on Steakhouse Hill. That's an old term for some of you. It's the hill north of Moscow, about 5 miles. They made 2 nice cuts there way back in the day on both sides of the road. And since it was the only decent granite outcrop, I probably went there 100 times, taking 101 students out. See, this is granite. Took engineering students out and say, why did they cut the road back 10 feet? Well, if you measure the fractures, they were to accommodate the things that slid down the hill. What I didn't know this, because I wasn't that interested, was how fast the granite was weathering right here under our temperature, our climate. If you look at this piece of boulder, that boulder was fresh when it rolled down the hill. And the trees back there tell you, that when I was here, there were no trees. Yet look at the decomposed granite underneath it. I used to go out, by the way, with a shovel and a couple buckets and scoop up that stuff for sand. And every year it just kept coming. You know, so even at the present day situation, we get a lot of decomposed granite. And I've got I want you to look at some cuttings and see if you can tell granite from decomposed. Now, one of these is busted up granite and the other is decomposed granite. See if you can see the difference. Anyways, you're probably skipping the next slide. I'm talking too much. In order to understand some of the things I talked about, this is a complicated slide, but we only need to look to the right. The left is all the basalt terminology. We're going to focus on the sediments today. And you get three terms: sediment, gold wheel, vantage member, sediments of Moscow. Those terms are defined by the basalt. So what happens when you get towards the mountain and there's no basalts in the subsurface? Well, you can't tell which one's from the other. They all look the same coming up the drill trips. They look the same if you look at them in outcrop. So the term lake tall formation is what I use here. I think Reed Lewis mapping uses tertiary sediments because you can tell they're sediments. You can't tell what unit you're in half the time. So you hear me use the word lake tall formation. Probably the next slide. I'm going to take a little drink of water. This is standing on Kamiak Butte and looking towards Twin Peaks. And just to remind everybody, looking across the Palouse Hills, you know that underneath the Palouse Hills is our aquifer system. In a simple sense, we got thick glass over top of basalts. And of course, we find out looking at the subsurface, it's a lot more complicated. But if you look up there closely, as you head towards the mountains, you'll see this little darker brown line up there. That's probably the close to the edge of the basalts. And then you start to see elevation rising through, I call them the agricultural slopes. And there are no outcrops on those slopes. Occasionally something washes out of the banks. And then you get up to the forested areas. Well, the forested areas, from my thinking, I'm going along with I'm satisfied with other people's research way beyond my abilities with isotopes and noble gases and so forth. Feedback has funded a lot of research up there in the mountain. That's where the recharge is occurring. And can even trace it back to Rothberg and Roy Breckenridge's work back in 2000, when they noticed all kinds of permeable sandy soils, lag gravels, and decomposed granite. So most of our recharge, not all of it, is happening up there. I understand in my mind the aquifer system down in the basalts, because I like to trace basalts. It's that agricultural slopes that bug me. Because how do we get the water up there down into our system when all the wells are low yield in that slope area? And after it was beat into my brains a couple times, there's no recharge on that agricultural slope. It's got a clay cap from the sediments of Bullville and from the Latol Formation. So there's no vertical recharge across those slopes. How does the water get through there? And so I started looking at the granite wells along with Pam. Pam put them in my lap and I tried to interpret them. So it's been slow because the granite wells are a problem. Let's see if we, next. This is where we're looking. This is a cross section from the end of the Idler's, was it Idler's Rest? Yeah, Idler's Rest Road. And the west end is down to Pullman Tesla. Pullman Tesla is halfway between Moscow and Pullman. So it's a northeast trending cross section. And the specific reason I put it this one up is that the real detailed cross section going into Moscow actually gives one false impression. It has the basalt, which there is correct, sitting right against the granite. Actually, that situation probably doesn't occur very often. If you swing to the northeast, you'll see the yellow area up there is the sediments. All the yellow is the sediment. You can obviously see that beneath Moscow, it's mostly sediment, not basalts. Mostly sediments. The blue is the basalt of Lolo. So where we're working on is the end of the Lolo flow up to the forested areas along the mountain fronts. So all that sediment in there, or decomposed granite. This was done 5 or 6 years ago, and I didn't think that the decomposed granite was quite as important as I think now, so I kind of slid it in there. And that little green layer, that's debris flows and decomposed granite. Now, this slide, you gotta realize, is 10x, so it gives you a false impression. It's actually would be, if we put the real scale, it will be sketched out from the end of that low, would be stretched out on a drawing about like that. So, anything else is going on? Oh yeah, we gotta look at a couple of exposures. No old-time geologist can give a talk without looking at a couple of exposures. Pam found this on the internet before we got here, a real estate agent advertising their site out on Westview Drive in Rolling Hills in Moscow. And when I was younger, would zoom out to look at those because it might be a stop I can show a geology student something because you can't see much around. So well, this is out there. You can see a picture on the right shows you about where it's at. And they're excavating it back for a house. What you see is alternating white and brown. The white layer you saw the kaolite going around. These are some clean sediments that come out of that brown area. So we're actually alternating sequences of clay, thick clay, thin layers of really coarse grain conglomerate almost. This is really coarse grain sand or conglomeratic sand. The brown is where the water is moving through at some time, leaving those iron stains. And show you how geology has changed. When I came here in 1967, this outcrop was mapped as granite. Because I used to see the white clay, eastern Moscow was considered to be under granite. I remember one engineer when I told him that the tower was under sediments. Just the face went white because he designed it for being under granite. And it was interesting. Turns out kaolite is pretty stiff. So when he ran his numbers again, he took a sigh of relief and it was okay because his first thought was, oh my goodness, we have all that weight on the sediments and it's going to slide downhill. It turns out kaolite is pretty tough. How much water comes through the sediments of Oldville in those sands, I don't know. But water moves through them. Lots of foundations in Moscow have spent fortunes because they didn't put their trench drain in right. Water comes through those layers in the springtime to get into the basement. It's been kind of a on and off discussion between hydrologists and myself to how much water actually moves through there. But this is a picture of what's happening in the subsurface. When we go through it, I've never seen an outcropping vantage here in Moscow Basin. I guess the closest one is over in Colfax. I've never seen an outcrop of the sediments of Moscow, which are down at the bottom. You're getting, your upper aquifer is getting almost all this water from the vantage. The lower aquifer is getting most of its water from the sediments of Moscow. So this is sort of an insight into what we see because you look at the drill chips coming up. They're usually messy because when they drill sediments, there's all kinds of water and sometimes soap. They put soap down the wall to help keep things moving. And what you're seeing there is a mess. The sediment descriptions are pretty poor. One of the Univive wells says it's logged from 800 feet, goes sediment, salt, sediment. Not exactly much for me to go by, but that's because it was also hard to see that sediment. But I did figure out over the years that most of the layers is coarse grain sand, like we just passed around, very poorly sorted, fines and coarses. That's pretty consistent all the way down through, and there's more coarse grain layers down at the bottom than there is on the top. But we have to go by what I can see, so we'll switch to another slide here. Yeah, most of you probably know there's your new road cut up there. You can't exactly run up there and look at it because you're still working on it. One of the reasons we came was Reed Lewis pointed that out to me last spring when I was just coming through for a visit. And of course, he got all excited because he can see hard rocks. I said, well, so it's granite. Then he told me the important part. And the next slide is the important part. We can't get a picture right now, but now let's look down to the left. Up there's his granite outcrop. What he told me was, as you come down that ridge and where the road's being put in, it's still some hard granite for a while. If I get this wrong, correct me. After you start getting farther and farther down, you get into a pretty thick sequence or a pretty extensive sequence of decomposed granite. So soft, you can almost take your hand and grab stuff out of there. And then I don't know whether you saw it or he told you that the basalt, did you actually see
I
it?
actually didn't see it.
Didn't actually see
It
the
was
basalt.
drilled. Yeah,
There's
it was
supposedly basalt exposed at the bottom. I've been working here in this area various times. All my drawings show basalt trying to thin out into the granite or sediment. I've never seen one. So the first thing I asked Reed, what these, well, they cover it up. So I still won't see one, which I've been drawing on cross sections for many, many years. But that encouraged me and Pam, well, maybe this decomposed granite's part of the story. We'll go and see that. So what was my timing? I'm not doing too bad. I have to watch the timing because I tend to talk and you never stop. Okay, so why are the interpretations difficult? When we started looking at the logs, it wasn't very easy. We have granite on top of basalts. We have decomposed granite by some drillers. They all really like to write firm versus soft because when they're drilling, the driller's more interested in where he has to put casing or doesn't have to put casing. He could care less if it's granite or decomposed granite. He wants to know where that casing has to go and is he going to hit water. So I just, to be honest, I was a driller, not very long, not very good. About turned over a rig one day, my first time on the job. But they see water coming out the bottom. That's water that they are injecting. And the stuff coming up now and then, you might ask the driller's helper to go and give them a sample. So how do you tell sediments from decomposed granite and from granite? Well, if it's white, it's granite, unless he actually sees some sand grains. So you get granite listed all the time. Well, if it's granite and it's soft, he writes down decomposed granite. If he doesn't recognize it as granite, he might say sand, or he might say gravel. Sometimes he'll get big quartz chunks coming, not this big, but he'll get big white quartz. So you look at a lot of the logs, he's seen that white chunk down there, he writes down quartz. Those are quartz. Everybody knows this. It's at everybody's lawn and walking around East City Park. Everybody's got pieces of this in their yard. They picked it up off of Moscow Mountain, where it's decomposed granite, and the stuff so resistant, it's coming to the top. The big chunks are from like pegmatitic granite or vein quartz. So the logs are difficult to tell what the driller's in. And of course, all of them have different rigs, all of them have different experience, and they got to fill out these logs for the state. Sorry, Chris, they don't always take the time to film on either whether in Washington or Idaho. They got a job to do. Nowadays, they push the buttons real quick if they remember to get their coordinates. The old days, you just kind of wrote down Radio Township at Christmas time. Because they don't got time in the summer, so they get home, they look at their notes. Oh, soft, what quartz must be granite. And they fill out the log. So I'm not knocking them because it's darn hard to stand there and look at that stuff coming out when you're more interested in the water, you're more interested in where they're going to put casing. The gauge tells them there's lots of water. I got watching that gauge, or you have to watch in the ditch. So anyway, immediately I found out it wasn't easy like the basalt. When they hit basalt, they know they're in basalt, and they hit this stuff, they're not sure what they're in. They still don't to this day, and a lot of professionals don't know. It's just a mess coming up out of the well. Well, we better move on here. Telling stories, Mike, you have to cut me off. Okay.
It's what I came here for.
Oh, okay. This is a little, you can't really see it all, but I'm gonna give you what we're trying to do. Pam sets up the drill log on one side, and then the left side is my reinterpretations. And we're trying to set up a set of about What are you gonna end up with, 150 maybe, or,
150, 200.
you know, and maybe get done by next spring? I've had to go back over them because at first I kind of struggled. If you read the one on the right, this is nice, it's typed, and you can read it. He hit basalt, so this is actually a basalt well, but he has a layer of granite, you can't read it, I know that well, about halfway up that lobe, but you can't have granite over basalt. So I changed that granite, he's seeing quartz out there. I changed that granite to sand or gravel. And what that does, of course, is increase percent of plastics that's in this case, this we know is settings of Wolville because I hit the basalt. And I know he's in the basalt, because you take the elevation, it's in the low, because you take the elevation, and the first thing that could be basalt, 2,500, that's pretty close to the top of the low. See what else I'm gonna say about this thing. But anyways, we're gonna get a log like this where it tells you what basalt unit is. Now we'll get to something a little more harder. Let's take the next, we got a whole mess of these, I don't know how many I'm gonna do.
6 of them.
This is the Ted Thompson well, this is located, on the southeast end, south of Rivers Road, about a mile from the basalts in Nice Valley. And if you could read that, descriptions up there, lots of clay, some white clay, okay, but it ends up in granite. So don't know which, it's just called Lake Formation, and over on the left, we just use the word Lake Formation. But I did change some things because he has decomposed granite up there in the middle of these sediments. Well, it's probably reworked decomposed granite, but it's no longer decomposed granite, it's a sediment. Because it's been transported somewhere, at least a distance. And the other thing we were trying to do, the hardest part of all, is when are we in hard granite on top? And the reason that's important, even though I don't think hydrology all the time, top of that granite is important because the granite itself doesn't transmit much water. So when are we on top of the granite? Maybe if we get lucky, we'll be able to make a subsurface topographic map, maybe if we get enough data. So I had to interpret, they got this decomposed up there, sitting right on top of when he says it's firm. Well, so I'm drawing the line, I'm saying the stuff above it is either sand or decomposed granite, I don't know. But the first firm is probably the top. And what makes that harder, if you're not familiar with granite wells, took me a while to get this, even after you hit the first firm layer, it's not solid granite all the way down. You get that impression if you look out there at the Steakhouse Hill. That's what I taught everybody. That granite extends all the way up over Moscow Mountain. Well, it does. But it's alternating soft and hard layers. Soft layers are probably, and I looked up international studies, it's pretty common in granite. Soft layers might be a little bit of water percolating through and soften it up, or it might be a fracture that started with a little bit of water, or just a little softer. But one thing common on all the wells I found out, they alternate this soft and firm. And so I just take it, if I find decomposed granite and granite, I have to estimate firm granite, I run a line there. Find another one, if you just jog on my memory, another one for a few minutes.
Can I ask a
Bill Bear.
ask a quick question?
Sure.
Is there, as with what you've looked at, is there a correlation between the widths of the soft and the hard granite? Has it been consistent at all, or has it just varied pretty greatly?
Somebody else tried that once because thinking there were fractures, and you can get some idea of the fracture spacing up on Steakhouse Hill, and then there's some outcrops in old quarries. And spacing in the wells don't match very well, but it could be the drillers. To every drill rig, soft and hard is different.
Yeah.
That's a great idea, Tyler, because they do have, no report talks about the spacing of the fractures. That was ideal. If you knew that spacing,
right,
maybe you could predict, but it didn't match the well log.
So it didn't correlate with the well log.
So they gave up.
Yeah.
That was my memory. Okay, this is just a simple one. Gail Byers, everybody, I think know Gail Byers, real estate agent. She lives out east of town. She's up pretty high, around 3,000 feet in elevation. This was one place that was easy. You go down dirt, clay, soft granite, a little harder granite. Okay, so the water was right on top of the little harder granite. So I'm guessing that the water was moving through the soft area or the decomposed granite. And once it hit hard, we'll call the contact there. So that place, but here's one that was dirty and I didn't know what to do. The soft area was 200 feet thick. Where do I draw? I can't believe there's 200 feet of decomposed granite there, but maybe it's possible. And I have to back over some of these and write down, make sure this was my guess. But I think this had almost 200 feet of soft material on top. The problem with calling it decomposed granite is that decomposed granite, if the clay's out of there, has a really high transmissibilities, really high permeabilities. But if the clay stays in there, it doesn't move. And we looked at an outcrop just yesterday, a great decomposed granite. I could take my hammer and go, boom, Pam took the hammer, I couldn't go across the ditch. She took the hammer and just drove it into the road, not that deep. But yet the clay was, this is right on an outcrop, the clay was still in there. That water wasn't gonna percolate through that, but I do know there were areas so soft and so clean, the decomposed granite has the possibility of transmitting water. So it's hard to pick it out. We better do one more, see 25 too. Yeah. Which one I want, Mike, I may make these switch around. Yeah, let's skip that one, that is too easy. Let's skip that one.
There was a hard one.
Yeah, let's take Lee. Well, Lee Sharp was pretty easy to, I think there's one more, maybe really hard to. Yeah, Steve Clark, just look at the Steve Clark one. This is right on your cross section. And he went through diorite. Well, I started looking, first of all, it's a hard time finding this well because the names changed and this one changed. He talks about gravels, clay and sand, and he goes, diorite. Well, sometimes there are mafic pods in the granite. Maybe that's what he saw. Then he comes down at the bottom and I think he said, oh yeah, he hits sand. I go, wait a minute. Sand underneath diorite's not possible. So back and plug the top elevation of diorite. It's a black rock if you're not familiar with salt and pepper. And the bottom elevation, oh, it matches the basalt layer. So what he was seeing coming up, and if you look at the low flow, sometimes not in very many, but it looks salt and peppery. He decided he wasn't in the salt. And then, so I've changed that back to pre-stratus basalt. And this well is getting this water from the Latol member of the Vantage. And that's the same aquifer that feeds most of the upper aquifer in Moscow, same one. And it's got a pretty good well. Anyway, what else did I change? I might have one more yet. Let's see.
That's the last one.
That's it, okay. We'll get down to results. I've given you some of the idea. We showed you some of the easy ones. I should mention that a lot of the logs start with granite, soft and hard for 400 or 500 feet. So some of those aren't useful. But this is what we've been doing, trying to reinterpret some of the stuff. This is more room for talk and questions here. One of the first things we found out, there's a extensive amount of decomposed granite. And if you look back, understand geologic history, think back when this stuff was, when the sediments were being deposited. It was humid, it was wet, it was warm. Same time these basalts were causing these sediments to form is I forget what they call it, the temperature optimum 16 million years ago, the hottest time ever for the last 20 million years. It was hot, it was wet, a lot of vegetation on that mountain. What's it doing to the granite? It's just beating it up and dissolving a lot of the feldspar. So you had a unique situation here in Moscow with so much decomposing of the granite. It put that clay into suspension. Normally, that white clay, that kaolin would just be going out the system. but there was very poor drainage to the west. So we come down off the mountain, and then Moscow, where Moscow is now, out over floodplains, in the lakes, ponds. So you get that picture we saw earlier of all the white kaolin, because the streams couldn't carry it out of here. Plus the weather was turning that feldspar pretty fast into clay deposits. When you go up even a mountain now, nice trails that weren't there when I was here many years ago. Next time you're up there, look around. Big pieces of quartz laying everywhere. Well, how far is it down to the granite? Solid granite, don't know. This could come out of a decomposed zone because it's last. It could be sitting right on top of the granite. It's only a few feet down. Present day, and dummy here, she doesn't like when I'm so dummy, but I went up to do some mapping there off Breckenridge. We were doing the official sediments. I was looking for solid rock. I didn't want to look at the sediments, you know. And what you find, what I remember, and it's what they report, you drive all over that forested area, there's not a lot of rock. It's thick permeable soils, it's decomposed granite. That's where the water is getting in. Right there underneath the snow melt, getting in right there. And you can always tell the granite's close if you see these chunks. If the people in Moscow haven't carried them all home, I know that everybody has them and they're all on. Okay, so decomposed granite is extensive. Lateral formations, that's much more extensive than previously believed. George Grader in 2012 pointed out that my contacts were too far away from the mountain. And he moved in. And then, of course, I had to show Reed this. Reed pointed out to me just last week on the southern end, I hate to say this, well, half a mile off, Reed, or 2 miles off. Because we didn't have the well data to have the lateral sediments on top of the basalts and interfingered basalts much more extensive than we thought. And I could add on to that, we're starting to see a lot more coarse grain material. It's a clay rich sequence, but there's a lot more coarse material in there. It's not unusual. Sediments are dissected alluvial fan deposits. Some people would just like to know what's down there. Well, what I like to know is helps me figure out what's down there if we have a proper depositional model. And it is really tough here looking at these drill logs, trying to figure out exactly how these things were deposited. Pretty clear in my mind, modeling using sedimentological models, that they are, when you look at those slopes, you're looking at dissected alluvial fans produced by the basalts blocking the drainages, and you're looking at a stack of 25 or more of them. You can't tell them apart, but I believe they're alluvial fans. I did feel better when Reed told me when he's trying to put some lines on there, it makes more sense that they were alluvial fans, even on the southern end. So that's just something I feel pretty strong with. But what you're looking at is dissected alluvial fans without much gravel, not even that much sand, because what was coming off the mountain is clay and fine grit. Because there's no conglomerates up there hardly. There's a few lag conglomerates, but it's different than looking at alluvial fan in the desert where they have gravel, sand, clay. It doesn't have a lot of gravel. Okay, I'm going to stick with it. I'm sorry, I keep confusing you. It's not unusual to find thick sequence of sediments right next to a granite outcrop or close. You look on one side of the road and up along the forested edge, and you see these boulders, what look like, there's hard granite. The well on that nearby says 20 feet of overburden. The driller didn't give any description, but he hits hard rock. Look on this side of the road, 500 feet away, and it's soft 200 feet. So it's really hard to predict continuity, but, and I have other examples I can give you, sort of anecdotal, but that there's a lot of places where it goes hard granite and then boom, straight down almost. It's either decomposed granite or it's alluvial fans going in there. And I can even tell you for sure I know that, because back when I was a driller and about turned over that drill rig I told you about, I was on my own with a new driller's helper up on the end of Idler's Rest. And it was going down so fast, I wasn't able to control the drill rig almost. Went 400 feet, never hit a rock. And I could stand there and look at a granite outcrop over there. And I still remember that well. I know where it's at. Of course, we don't have it logged. What the drillers did in those days oftentimes is see how we word this, it didn't hit water. So what drillers do when they don't hit water sometimes is to make it, they don't want bad press. So maybe drill you another well or they'll go half price. Now, part of the half price is because I got it done in one day and was supposed to take 3. But you want to keep things, so you don't turn in the log, the well was never drilled. Because the owner still has a permit for that log. Just logical thinking from their end. So that log is not in the system. Oh boy, get me going here. We got 5 more minutes. What we do know now is that I thought the basalts were complex, but the wells are penetrating some sort of complex 3D mosaic of atoll sediments, decomposed granite, and real granite. If you're really going to understand it, I think we'll get a better overall picture. We're going to have to draw some detailed cross sections in areas where there are clusters of wells. That forced me to do some detailed work. I like to go arm wave, point up there's this and this, and make some kind of model. We're going to have to take areas. There's lots of areas now where there's clusters of wells. So, and a lot of them aren't in the system, but there's enough now. I think I need to do some detailed cross sections. I even have this thing I was gonna list, maybe I'll say it out now, out of the box thinking. The recharge from the mountain coming down into the system may not be near the streams. It may be in those spurs that are coming out. All the sediments and material hasn't been eroded. The streams are in granite. They have eroded down in, we have been focusing on that. If I'm going to find recharge, I want to measure that water coming out of that stream. Well, if they don't lose going across that contact, there's a couple of hydrologists that pointed out to me, John, you can't have recharge there. We're not losing any. And it's all clay. So how's that water getting down here? It may be coming actually down in the areas that are on topographic map, they sort of run out from the canyons. That's where the water up here in the decomposed granite and the sediments may be working its way.
Is it what Jeff calls the paleo channels?
What's that? Well, they would hit either the decomposed granite or one of the sand channels in the latol. And instead of being held back all the time, they are held back a little bit by the clays. But you go through the clay and you hit some decomposed granite. It gets it from the first of all, we got to get it from the mountain into those. So we hit these more porous areas and it starts working its way down. And by the time it gets out in front of that spur, there's no water out there. It also hits a clay layer. And sometimes it does go out, but it's not going out the side into the stream. Some of it's going into the stream, but it's not getting down from those streams, at least not at that point. I mean, the logical place you look, the head of Paradise Creek, the head of Missouri Flats Creek, that's where you want to look. That's where I've always looked. But it may not be occurring there or right at that point. It may be also occurring along the spurs. I should have put that in the next one, Mike. I should have put that on what our brain's been working on. Yeah, these things that go through our head, because I call the other ones preliminary results because we're still just working on it. And so this is the working models. One thing I had to verify, I think, one thing we feel sort of comfortable with, when you get into real granite, low yield wells, they're probably mostly coming from soft zones and fractures. And I'll stick with, I think, Dale Rawson's old philosophy is that granite wells, once they're into hard granite, they're probably not connected to the aquifers down in Moscow Pond. But that's one thing we still have in our head, and we found some verification of that. The coarse grained sediments and decomposed granites form a 3-dimensional maze. In this case, it's the small pathways. Aaron Brooks, the soils person, I think he was the first to talk about water's getting down these channels, this maze of little channels, and that's how it's getting across there. Maybe you have thousands of little channels. So those may be the pathways for transmitting the water. And that's probably the one I like best. Coarse grain sediments and decomposed grain is like sieve deposits. And I'll explain what a sieve deposit is because it just recently came into my head. In alluvial fans, near the mountain fronts, both in the areas where the water is coming out and sometimes along the spurs, there's so much water when it's running high that whatever is the coarse material gets flushed, the matrix gets flushed, clay gets flushed out. And in alluvial fan models, right near the mountain fronts, there's a thing they call sieve deposits. Well, the word tells the truth. The water goes right down. It doesn't, once it gets there, it works its way down, close to the mountain front. And sieve deposits are, from what I can read, have been identified in many places, but not everybody agrees how they form. Maybe there's some sieve deposits, so we haven't found them yet, for sure, I don't think so. And then say, oh yeah, another one. There are another idea. And this comes from George Grader. He thinks that he discovered 3 paleo valleys going up, one of them up to Naylor Farms, if everybody remembers the Naylor Farms issue. He thinks there's some paleo valleys and the water get concentrated in there. We haven't found those yet, but got to keep our open mind that maybe that's where the water is coming. And then maybe it's all of the above, and that's why I'm confused. One last slide, I think. Let me see. I've been using alluvial fans were just an issue on the right. Of course, that's in the desert. But it shows you how many channels there are in alluvial fans. And if we have made alluvial fan every time there was a basalt coming into the area and damming it, you got 25 of these stacked on each other and then erosion, stacked and erosion. So maybe Aaron Brooks is right back there once what you have. In the maze of these channels. And then you look along this, the one on the far right, you'll see the channel coming along the mountain front. It's sort of, sometimes they turn and they run right along the mountain front. Those areas will be it's likely to be will be a sieve deposit if there is no. I think I'm wound down. So you know, last time we'll ask for questions. I think it comes along on the end. I actually made my time. That's unusual for me.
I think somebody may have posed a question online.
I'm gonna stop. What am I gonna do? Do this.
Oh, hi, John.
Question. Means that.
I think you mentioned George Grader pretty well after I wrote that note. He took me to a field once. And said, here, drill a hole here. And then within 8 feet, we had a gravel layer with water running underneath the soil in August. So I'm not sure which of these valleys I was in at the time, but he seems to have had a really good sense of where these might be with.
Yeah.
So it's a pretty interesting connection to what you're talking about.
Now I'm trying to find those valleys once we start to put the logs together. Did I answer his question or not? I didn't hear you that well.
I think so.
Okay.
Any other questions for Professor Bush?
I have one for John. Can you laugh with me when we used to think that all of the hills going up to the Granite were less hills? Yeah. Shows you how things change with time. We used to think from Moscow up, going to the mountain, that those were not sediments underneath there, but those were thick sequences of loess. Well, the loess is about that thick in some of the places.
Yeah.
One of the things that might help a little bit is if you look at the clay deposits from just east of Moscow all the way to Beauville. Because the Miskelcell pit, which was Simplot's primary one of the best clay deposits out there, and it's all kaolinite, is a reworked deposit, and it's almost pure clay.
Yeah.
And so you can get a lot. The other thing, I did a study a number of years ago on bricks. Every one of these communities made bricks. And one of the things you could look at as far as outcrops go is go take a look and see where their stuff was coming from to make their bricks, because the brick plant was always real close, as close as they could get to the source. They couldn't transport it any distance. For example, Uniontown had a huge brick operation over there, ran for years and years and years.
Troy made a lot of bricks.
So, well, yeah, and all the way Troy, and then, of course, Simplot had one out there, and there's been many others. Genesee had a brick plant.
I think Palouse did too,
Everybody-
even had, at least they had a clay pit. I don't know if they had a.
Yeah,
I've heard that some of the early WSU campus buildings, they had a kiln right on campus.
Yeah, they dug it right from there.
oh, the huge one was right just off campus.
There the U of I,
Ran-
they
there were
still
two
had
of them.
they were getting the bricks in Troy, they were making the bricks in Troy, there's still bricks that are stamped with the Troy, Idaho stamp on them.
The clay for Moscow, the wall came from out Troy.
Okay. Where was the Simplot mine that you mentioned?
It's how, it's just this, it's 5 miles this side of Bowville.
Okay.
And there's a good road, there's a company, Unum Incorporated, that has been looking at the possibility of reopening it.
Okay.
And they never, the clay as kaolinite is used, used to be used for making paper. And that was the big market for it. And of course, we don't want acid paper, and that's what makes paper acid is because it's got clay in it. So now we've gone lime, so that killed that whole market. But there's other markets that have come up. And the other problem with not doing it is Georgia clay deposits are superb and they're huge. And so every time somebody tries to get into business with clay, Georgia producers will just lower their price down, drive them out of business, and bring it back up.
They looked at Eloy's site too.
So
It's
I should point out too, that not all those brick things were out of granite clay. That you can make bricks, reasonable bricks, out of basaltic clay as well. So.
And one of the reasons that people did think that it might be economical is they think they could beat white clay, sometimes used in ceramics in Japan,
Yes.
China.
Yeah.
They thought, well, because we're closer to the Seattle, we can beat Georgia
Yeah.
and get it on the train here and get it out to Seattle. But I think Earl hit the right thing though. Georgia's a pretty big company. Gonna have to really cut the cost.
They're still working that angle out there. I
Are
know.
they still working
Yeah.
on it? See, the regions I named them, the sevens of Oldville. That was at one time, I don't know now, was where the best outcrops were. In Moscow, you might find one if you happen to be out there when they're backhoeing, there were no outcrops. So I preferred, since we mapped them all across the county, we mapped them out to Bowville, I preferred to use the name sediments.
Yeah.
Of Bowville, that's where my name came from anyways.
John, I have a question. So this is really great, and I'm so glad that you were looking at all this. You thought this was interesting and fun.
Yeah.
So my question is, okay, so the decomposed granite, if it doesn't have clay, it's great, it's porous. If it has clay, it's not, and it's
Yeah.
not gonna recharge water. And then you said with the alluvial fans, you don't have the gravel and the sand.
Well, okay, you have to change the model a little bit because if there's no gravel coming down from the mountain, if it's already so decomposed that all you got is clay and a little bit of sand or silt, that's all you're gonna get in your fan. So the models that you generally see is gravel close to source, sand channels, and overbank clay. Well, we got a really clay-rich system, really, and it's always been told to me, you can't transport water, but there are sand layers in it. And there are silt layers in it, coarse silt. If it gets fine silt, I understand, then transport water. So in this model, we're coming down with a stream where the channel deposits are not gravel. Channel deposits are primarily sand, maybe even fine sand and clay. But as it hits that mountain front, it starts dropping out the coarse material. So you still get channels of the coarsest material. And then they overflood and all that clay goes out of it. And at one time, Moscow, if you happen to be here then 16 million years ago, it would have been white plains during flood time.
So then it would be porous underneath. It's like the clay
But
would
that
be.
sand layer now is porous, so that channels migrate with time. So sooner or later, it connects. I mean, it makes a layer. Then if you notice from all the world data, even on campus with Vantage or whatever, they don't go very far. So there's sand layers that pinch out because remember 101, if this is a gravel deposit here and it got clay above it, somewhere laterally from that sand is a clay. and somewhere laterally from the clay is sand. So the data tells us that they don't go very far, but they gotta be interconnected somewhere, as the environment migrates back and forth. So in my mind, the water percolates through all of those and on down. Now, there's a problem with that from your view. What's the water levels in those granite wells? They're very high. Low yield wells, they're sitting up here at a water level that's higher than down there. And Dale would tell me they're not connected because they should be, if this water up here is getting down to the Grand Ron, they should have the same water level. And I have this for, I'm not a hydrologist, as you know. I see this big bathtub, suddenly it's going out like this, with just a couple of drill holes in it. So there's more water coming in, and there's less water leaking at the bottom. So the water level stays high in the bathtub. You drill 2 holes in the bottom, and it's leaking, but it's leaking less than the faucet is running the water in. So I don't want to disagree with Dale, but in this case, I think he may be wrong. I think they're connected, but they're not the same water levels. I mean, that is a problem. Every one of these wells, water level is like 15, 20 feet from the top of the well. You get down into Moscow, as you know, you gotta go, what is it? Getting down to 2,230 feet to hit the Grand Ron water. So how's it getting from up there down? My only thought is it's all this maze.
Yeah.
And they're not that well interconnected. They're interconnected enough to let the water through. Does that, I like talking to you. Always get me sidetracked. I can talk too much.
No, this is really, that was good. Yeah, that helped me understand the alluvial bands a little better.
So help me understand, the clays, are they a different chemical makeup than this? Are they just really fine?
Yeah, really fine material, impermeable.
Okay,
And some of the water, I think Aaron Brooks talks about this. Some of the times he would punch, remember, he's dealing with the soils, but he did recharge things. And what he'd do, he'd punch down into a sand layer. And some of the sand layers didn't change over the summer. So he would call that a confined, it's trapped in there between some of the clay. But other ones, he calculated up to 4 inches, 5 inches of percolation going on. So those he would run off of the forested area and say they're going down, hitting another sand layer because it's taking the water.
okay.
Yeah, so the clays have always been a problem because to some people, there's so much clay, we can't be running the water through there. I think Aaron Brooks was one of the first to say, wait a minute.
Okay.
You can get the water through there. Nobody's, to my knowledge, well, I forget that. I think Jeff Langman may have tried to correlate, calculate how much. Yeah, his work, I think Duckett's work, I think they try to make an estimate. I'm gonna pull this out of the air here. I think it's something like 60% of the water getting into Poland, getting into Moscow can be traced back to snow melt.
Okay.
So somehow it's getting through there.
Yeah, thanks.
Oh, John, before I have to leave for a 4 o'clock call, but we recognized you at the water summit
and I
last
wasn't
week.
there.
And you had snuck out beforehand, but this is our Water Advocate Award on behalf of the Palouse Basin Water Summit Committee. So thank you for all the work you have done.
Well, thank you.
Yeah, thank you.
So when I was younger, I got tired and had to leave.
It's all right.
Well,
There's a case here too. There's more. Excuse me, I think. I'll put it in the car. Thank you.
yeah. Wow. Wow. I really appreciate that.
It was freezing. We had to leave.
Yeah.
Nice to meet you.
When they announced it, I said, I looked down where we were sitting down there, I said, oh, no.
I know, because
I said, it's nigh on to 8 o'clock, I know what happened.
Exactly.
We're gone.
While we still have the Zoom on. Okay, thanks, everybody.
Thank you all.
So I think you said you, if people had any other.
Questions on anything, yeah.
And the decomposition, is that